Looks like the Iron Man loves my guitar. Bye guitar, I miss you. Anyway, hi, I'm Kenny. Welcome to iotbreaks channel. In this video, I will show you how to build a simple application that detects motion and sends notification to smartphone using Raspberry Pi 3 and camera module V2. If there are someone or something moving in your camera setup area, you will get notified to smartphone. The notification comes with text, still image, and the video that you can view directly on your iOS or Android phone. It doesn't matter. The application is pretty simple. It utilizes the free software such as picamera, ffmpeg, and the Pushbullet. All are free. I will walk you through the app architect, the flowchart, and I also explain the main functions I write in Python. It's pretty simple. At the end of this video, you can build your own application based on the instruction, or you just customize something of the already built software. It's easy. So let's start. There are three actors played together to build up the application. First, Raspberry Pi and camera module is data source that continuously scans for motion and record video at the same time. Second, Pushbullet, that is message broker to send messages back and forth between Raspberry Pi and mobile. And the third one is mobile application and web browser that receive the image and video motion. If the motion is detected, Raspberry Pi will send the text, image, and video of motion to Pushbullet, and then Pushbullet will notify to mobile. This is two-way communication though. That means you can send back from your mobile the command to Raspberry Pi like snap or check, and then Raspberry Pi will capture an image or check the information of system and send back accordingly. And that's all. About the hardware, I built this project with the mind that minimize the required hardware. So the list is simple as Raspberry Pi 3, a camera module, an SD card, and power supply, of course. You can check the hardware I have listed in the tutorial for the link detail. Optionally, you can trust your Pi with the fancy case or just a simple case like this one. But we should give the Pi CPU a heatsink to cool it down. This especially needs for long run. About the software, I recommend you download the ready-to-work image for Raspberry Pi at resources section. That I prepare everything you need to start it immediately. It saves you a huge amount of time from downloading, compiling, and facing the errors along the way. If you want to set up the environment yourself, it's fine. This application built on top of standard Jessie, released on 2017 April, that you can download from the official website of Raspberry Pi. We also need the ffmpeg to convert the video from X264 to MPEG-4 to view directly on your phone or web browser. We need the Pushbullet Python library for notification. One reminder for ffmpeg, the ffmpeg is not ready to install via apt-get command on Jessie at the time I make this tutorial. You have to compile it from source code. You can check it out how the ffmpeg can compile on Raspberry Pi and follow the way, and it takes 3 hours. Okay, and Pi camera notification and Pi camera notifier is the application source code I commit in the GitHub. You can get easily. And finally, you need to set up the systemd to start the application, right the Pi up, and that's all. And now you need to create the access token by go to setting and account, scroll down and create access token and copy this token somewhere. We will use it later. We need the application on iOS or Android too to receive the notification. So just install it from App Store for iOS. Now remember to register to log in with the account you just created. And make sure you select all devices here. Let's download the ready-to-work image. Go to tutorial on iotbreaks.com and scroll all the way down to resources section here and download the ready-to-work image for Raspberry Pi. Picamera Notifier V1 image. This file size is pretty big. It's about 2.7 GB. After you download successfully, let's unzip and flash it to your SD card. I use the SanDisk micro SD card 8 GB, so it should do you. Just in case you don't know how to flash the image to Raspberry Pi, refer this tutorial on iotbreaks, how to install the Raspbian to SD card for Raspberry Pi on Mac. For Windows users, you can Google it. It's quite easy. Let's take a look how it works. Insert your SD card, power Pi up. Just wait. It will launch screen to the desktop X in chassis. And you can see the picamera notifier folder at the desktop already. So now you need to replace your Pushbullet token access. You can see Pushbullet key, and I write here for example and replace it by yours. Save and reboot. After reboot complete, take a look at Pushbullet application on your phone. Yeah, picamera notify abstracts. Let me try to moving something in the camera view to see what happens. Yes, I do receive the notify really fast with the text, hey, something in my room, yeah. Let's take a look what I got. Wipe it dry. This message will come with the still image. Take a look. Oh hey, look like the Iron Man. I want to snapshot what happened in my room, so the Pi will capture the still image and send me it immediately. Hey, where does this Iron Man come from? Just wait some seconds. I will receive a video that records about 10 seconds of moment the motion detected. Just wait. Yeah, here we are. The motion is out. Video uploading. Let me download it and view it right away. And open it by quick view. Huh? Are you kidding me? Hey, this is the cute Iron Man I ever seen before. With a Doraemon shirt. And she loved my guitar too. So that's it for the demo. If you want to learn how to make it yourself, this section is for you. In this section, I will go through very detail about the source code, a flowchart, and how the things come together. At the end of this section, you will be able to customize the source code, change the parameters, the size of the image and the video, and how do you want to store the file, anything you need. So let's start. When you start the main.py, the system takes about 2 seconds to warm up the camera before it works perfectly. So it jumps right into the motion scanning state. When motion is detected, it will capture an image and upload to Pushbullet and send notification to your phone. And then I will schedule a timer of a few more seconds to record more video about the moment that motion happens. After that, I will upload that video to Pushbullet and notify again to your phone to make sure that you know the motion is end. So the system will will go back to the motion scanning state to detect the further motion. And that's all for channel for flowchart. This is the active diagram of main.py. At app launch, I initialize two important objects, camera and notification handler. Those objects are used in all functions below. First, set up notification handler. I create this object with two input parameters, Pushbullet key and did_receive command. Pushbullet key is the access token you create on the Pushbullet website, and did_receive command is callback function that will be called when you text a command from Pushbullet app to send it to Pi. Second, I initialize the camera object to detect motion and to record a head into the circular buffer. The reason we need to record a head because we have no way to predict when something will happen. So we have to record in advance into the circular buffer. Now the camera object is available to record it. You can see here, we start recording to motion detection class. This is input for motion detection. And we also start recording to the stream. So at this point, Pi will push a notification to Pushbullet app to inform it's up running and ready to detect motion. This is flow of motion detected. When motion is detected, Pi will push an image, a message to inform the motion is detected. Hey, someone sneaked into your room, check it out. And then it captures a still image with file name input to push that image accordingly. Until then, we wait for 7 more seconds so that we make sure we capture the motion. And then the write video function will be called. This function will do two things. First, it saves the stream into file and convert this file from x264 to mb4 so that we can view directly on your phone, on the phone or web browser. And the second task of this function is it kill a push data. That's a video and a message to your Pushbullet app to inform the video is end. So that's it for motion detected flow. This is the flow when you type the command from your phone. It's sent to RaspberryPi and this flow will be executed. If you type the check, I will call the system info and send back to you with a text message like this: temperature, RAM, CPU usage, and SD card free and total. Something like this. If you type the snap, I will capture an image and send back to you immediately. Otherwise, I just print out the command not supported. and that's on for the command receive processing. Let's summarize what we get to now. We have the real application that detects motion and notifies to smartphone. It runs on Raspberry Pi 3, but I think it can work normally on Pi 2 or Pi 0. You may wonder if the application is real-time. No, it's not real-time, but it's fast enough to detect, to know what happened in your camera setup area. The application doesn't require the coding skill, but you can change the source code if you need. Until now you get the flowchart, you get the architect, you get the source code, and especially how things dance together. If you get stuck somewhere, just write your question below and I will read and answer it. If you like the video, please subscribe the channel, share and thumbs up. That will inspire me to produce more helpful videos. Have a good time. See you in the next video.